This is screencast number 1 on basic percents. We will be opening up the unit on the Common Core State Standard 7RP3, which is using proportional relationships to solve percent problems. To start the unit, we will set up simple percent problems as in problem number 1. We will do this by constructing a table of equivalent ratios. Within the table, we know that all the ratios are proportional, meaning we can multiply or divide to go from one ratio to the next. First, we are going to create a table and label our numerator as the whole and the denominator as the percent. We know that percents are out of 100. In question number 1, it asks, what number is 20% of 80? So we know we are trying to find what number is 20%. Since we do not know what that number is, we are going to leave the numerator blank, and in the denominator, we're going to type in our 20%. The number 80 is the whole, so it's going to go in the numerator, and we know the whole is out of 100%. To find out what number is 20%, we can use proportional relationships by scaling up or down the numbers in our table. We are going to focus on scaling down to the unit rate of 1%. We can get 1% by taking 100 and dividing it by 100 to get 1. So 100% divided by 100 will give us 1%. Whatever we do in the denominator, we also have to do in the numerator in order to keep equivalent ratios. So now we have to take our 80 and we have to divide it by 100. So 80 divided by 100 is 0.8 or 8/10. Once we know 1%, we can either multiply or divide to go to another percent. So we can easily take our 1% and we can take 1% to get us to 20%. So we can do this by taking 1% and multiplying it by 20. Again, whatever we do in the denominator, we also have to do in the numerator. So now I'm going to take my 8/10 and I'm going to multiply now 8/10 by 20. And that is going to get me 16. So to answer my question, what number is 20% of 80? Well, 16 is 20% of 80. So then I'm going to write my answer on the line, 16. Looking at question number 2, what number is 15% of 45? A similar table of equivalent ratios are going to be created. The whole is going to represent the numerator, and the percent is going to represent the denominator. So we are trying to find out what number is 15%. Since we do not know what that number is, we are going to leave the numerator blank and put 15% in the denominator. Next, we know 45 is going to be the whole, and one whole is 100%. Again, we are going to focus on scaling down to the unit rate of 1%. So if we want to go from 100% to 1, we're scaling down, meaning we're going to have to divide by 100. 100% divided by 100 will give us 1%. Whatever we do to the denominator, we also have to do to the numerator to keep it equivalent. So 45 then divided by 100 is going to give us 0.45, or I can say 4,500. Next, we're going to take our 1% because now we can easily scale 1% up to any number. Our goal is trying to find 15%. So if we want to go from 1% all the way to 15%, we can multiply 1 times 15 will give us 15. Whatever we do in the denominator, we also have to do in the numerator. So then we do have to take our 4,500 and multiply that by 15. And we can do this by entering it into our calculators. So then we have 45 hundredths times 15 is going to give us 6.75, or we can say 6 and 75 hundredths. So to answer our question, what number is 15% of 45? Well, 6 and 75 hundredths will be our answer, and then we can write it on our line. So 6 and 75 hundredths. Question number 3 is a little bit different. It is now asking for a percent rather than a number. We will again continue to use tables of equivalent ratios. Again, we are going to label our numerator the whole, and our denominator is going to be the percent. Here, we do not know what percent. We want to find 12 is what percent of 40. So if we do not know the percent, we are going to leave the percent blank and put 12 in the numerator. We do know that 40 is our whole. So 40 is our whole number, and one whole is out of 100%. Next, we are going to scale down to 1%. So going from 100 to 1%, we can divide by 100. Whatever we do to the denominator, we also have to do in the numerator. So we can take 40, divide it by 100, and if we take 40 and divide it by 100, we are going to get a decimal, and that is going to be 0.4, or we can say 4/10. Next, looking at this table of equivalent ratios, we are trying to get from 0.4 to 12. That is not as easy going from a decimal to a whole number. So maybe I want to create another equivalent ratio that will help me get up to 12. So I'm just going to insert another column in my table to the right. And I do not want a decimal as an answer. So now I'm going to scale up my percent. Let's see what 10% is going to be. So now going from 1% to 10%, I can multiply by 10 because 1 times 10 is 10. Whatever I do in the denominator, I have to do in the numerator. So then if I take 4 tenths and multiply it by 10, 4 tenths times 10 is going to give me 4. Now I have a whole number, which will make it easier to scale up to 12. So 4 times what will give me 12? Well, I know I can go from 4 to 12 all the way over here by multiplying by 3. 4 times 3 is 12. Then whatever I do in the numerator, I have to do in the denominator. So then I can take my 10%, multiply that by 3, and 10% times 3 is going to give me 30%. So now to answer my question, 12 is what percent of 40? Well, 12 is 30% of 40. So my answer right here is going to be 30%. Now in question number 4, it is asking 9 is 15% of what number? So again, I'm going to set up our table to try and set up equivalent ratios. My numerator is still going to be the whole. My denominator is still going to be the percent. This time we know that 9 is 15%. So I can type in 9 is 15%. We are trying to find what number, so we are trying to find the whole 100%. So again, I'm going to go down to my unit rate of 1%. I can easily go from 15 to 1 by dividing by 15. Whatever I do in the denominator, I have to do in the numerator. So 9, then divided by 15. I'm going to divide this. And again, it is going to give me a decimal, which is fine. So I'm going to type it in here. 9 divided by 15 is 0.6. Next, I can scale up 1% to 100 by multiplying by 100. So